Quick revision video on further titration calculations. So these are just a little bit trickier than the normal calculation questions. Essential formulae. So we're going to use the one for aqueous solution. So that's moles equals concentration times volume. And just remember that volume has to be in cubic decimeters. So if you're given the volume of the solution in cm cubed, you divide by 1000 to get it into dm cubed. The other formula we'll be using is the solids formula. So mass is equal to moles multiplied by molar mass. And just a reminder that the mass has to be in grams. So before we go into the questions, I'm just going to go through the process that's typically involved in these types of calculations. So they normally start by a solid being dissolved in some distilled or deionized water. That's then transferred into a volumetric flask, and obviously the volume of the volumetric flask would be given. And then that solution, a portion of it can either be measured into the conical flask, or it could be used to fill up the burette. And then obviously the final thing that they would do is perform the titration. So there's a couple of examples if you wanted to pause the video and try them, and then play on when you're ready for the answers. So the first one, we've got to calculate the relative formula mass of M2CO3 and then identify the metal M. So we've got the mass of it. So to get the MR, we need to know how many moles are in that 7.46 grams. So that's what we're heading for with this calculation. Now, in my opinion, it's always a really good idea to just do a little sketch of the process. So what I would encourage my students to do is just draw little sort of diagrams, just very simple diagrams, so you can sort of visualize what's happening. So we've got 7.46 grams of the carbonate. It's been dissolved into 1000 centimeters cubed, and then a 25 cm cube portion of that is transferred into the conical flask, and the titration's been carried out. So the first thing we can do is work out the moles of HCl in that 27 cm cubed. So that's concentration times volume. So it'll be 0.0027. Remember, the volume's got to be in decimeters cubed. The mole ratio in the chemical equation is telling us that the moles of M2CO3 in the 25 cm cubed used for the titration will be half of that. So that's 0.00135. And then the number of moles that must have been in this flask here is going to be 40 times that, because 25 cm cubed is a 40th of 1000. So the moles of M2CO3 in the 1000 cm cubed and also the 7.46 grams is 0.054. So just remember those 7.46 grams of the carbonate dissolved in water, and then they're literally just poured in there. So the moles in these two containers are the same. So now we've got the moles in the 7.46, we can work out the MR. So that's 7.46 over the moles, 138.1. So now we've got the MR. If we subtract what we know, so we know that there's a C and 3 O's in there. So the MR of the two M's is 138.1 minus the mass of CO3, which is 60, so that's 78.1. So each M must have a mass of 39.1. And to identify the metal itself, we've got to factor in the formula. So it's M2CO3. So that means M must be in group 1 to 1 plus ion, because there's 2 of them for every carbonate ion. So M is potassium. So the second one now, we've got to work out the value of N. So in other words, how many CH2s are in the formula of succinic acid. Obviously we're going to need to know the MR, and then subtract what we know from the formula, and then we can get a value for N from that. So as before, I'm going to just use some little pictures to help explain what's going on. So the 2 grams of acid is dissolved in some water. It's made up to 250 in a volumetric flask, and then this time it's going into the burette, and the titration's carried out on 0.1 mole per decimeter cubed sodium hydroxide. So that's obviously in the conical flask. So the first thing I'm going to do is work out the moles of NaOH in the conical flask, concentration times volume. So that means the moles of the succinic acid that are in the 18.4 centimeters cubed is going to be half of that from the mole ratio. So now to get the moles of succinic acid in the 250, it's not a straightforward conversion this. So we know the moles in 18.4. So if we divide by 18.4 and then multiply by 250, we'll get the moles in the 250. So the moles of acid in 250 and also the 2 grams, remember it's dissolved in here and then just poured into there. That's 0.00125 divided by 18.4 times 250, 0.01698. So now we know the moles and we know the mass was 2 grams. The MR of succinic acid is 117.76. So now we know the MR of the acid, we can subtract the MR of the two COOH groups, which is 90. So that comes out at the CH2N part having a mass of 27.76. The MR of CH2 is 14. So if we divide that by 14, we obviously get a value of 2 for N.